Okay, so here we have a histogram and we sort of talk about the distribution of the histogram, and included in that we talk about the shape of the histogram. What's that say? Examining a distribution. In any graph of data, look for the overall pattern and for striking deviations from that pattern. You can describe the overall pattern of a histogram by its shape, its center, and spread. An important kind of deviation is an outlier, an individual value that falls outside the overall pattern. So some distributions are what we call symmetric, and some are skewed. A distribution is symmetric if the right and left sides of the histogram are approximately mirror images of each other. A distribution is skewed to the right if the right side of the histogram, containing the half of the observations with the larger values, extends much farther out than the left side. It is skewed to the left otherwise, in another way. Okay, so looking at, for example, what's this? Iowa test scores. Anyway, this is a distribution of some variable. The variable is along the x-axis. So it's something about somebody's vocabulary, some student's vocabulary scores, that apparently the score is somewhere between 2 and a little bit bigger than 12 or something like that. And the y-axis is the percent. And so we have a distribution here. And this one we could probably call symmetric, or close to symmetric. Okay, this one, I don't know what we'd call it. I don't think we'd call it symmetric. We might call it skewed to the left, but maybe not. Okay, they talk about something called a stem plot, which you can do for quantitative variables. I'm not really going to go through that. Looks like this. Or anyway, we're not. So this one here, we would say is skewed to the right. And I guess this one would be skewed to the right. And this one here, D, is probably skewed to the left. But it's not a very good example of that. Okay, now besides talking about symmetric and skewed, can we describe a distribution with numbers? So one thing we can talk about is the mean of the distribution, which just means the ordinary arithmetic average. On the other hand, we can also talk about the median, which is, I assume you know what the median is. Then we might compare the mean and the median. And the mean doesn't have to equal the median. If the distribution is perfectly symmetric, then the mean and the median have to equal each other. Must be equal, but otherwise they don't have to be equal. And if the data is skewed to the right, then the mean will be greater than the median. And if it's skewed to the left, the mean will be less than the median. That's a visualization, rather, of that data. Okay, the standard deviation. This is the formula for the standard deviation. You know, what we're trying to do when we talk about the standard deviation is measure the spread of the data. How spread out is it? The spread of a set of data is the standard deviation. And here's the formula for it. You take each piece of data, which is indicated by x1, x2, that's the second piece of data, all the way up to the last piece of data, xn, and you subtract the mean of the entire data set from x1, You subtract the mean from x2, and so on. So what you get here is called the deviation of x1 from the mean, and the deviation of x2 from the mean, and so forth. And you square to get rid of cancellation, and we divide by, and you add them up, and then you divide by n minus 1. There's a question about why it's n minus 1 versus n. It's supposed to give you the average deviation from the mean, or actually the average squared deviation from the mean.